Good morning or good afternoon. Thank you for joining this SimScale demo and discussion session. Let's make a start on the actual presentation. Some housekeeping first. If you've got any questions as we're going through, please feel free to ask your questions on GoToWebinar, and we'll address your questions at the end of the presentation. It's fantastic to see so many of you here today, so thank you for joining. Go to the first slide, please, Darren. Okay, so I'll be hosting you today. My name is Steve Lenne, and I'm an application engineering manager here at SimScale. The star of the show and the main presenter is going to be Darren. Darren's an application thanks, Darren. Darren's an application engineer. He's experienced in CFD and engineering design, and Darren studied aerospace engineering at Brunel University, and he's a valued part of our application engineering team here at SimScale. So first of all, who are we? Well, SimScale is a Munich-based company. We were founded in 2012, and we've got a global presence and global footprint. There's millions of simulations being run on SimScale, and we've got funding, so we're going to be here to stay. What do we do? Well, at SimScale, we created the world's first cloud-based engineering simulation platform. This platform allows you to do CFD analysis, FEA analysis, and thermodynamics, and everything is accessible via a web browser. There's thousands of organizations that trust in SimScale and use SimScale to run their simulations. There's a selection of some of these brands that trust us on the screen now. So what's SimScale actually used for in these organizations? Well, SimScale can be used to accelerate your design process. It can help you to easily test the performance of your products, optimize products for durability, and improve the design efficiency while leveraging the capabilities of cloud-based simulation. How does this compare to traditional simulation and CAE tools? Well, traditionally, you have high fixed costs for CAE hardware and software. You need to purchase special hardware, and you need to install that on-premise. There's software installation and maintenance to be concerned about, so you have to keep your software up to date, and you have to install it on your on-premise hardware. Typically, these CAE tools are built for specialists, and that means that they need to have extensive training and experience to be able to use the software to its full potential. And computation time is typically measured in days or weeks, and it's difficult to parallelize simulations because your CAE hardware and software is occupied during a simulation. In comparison, SimScale offers a number of benefits. There's no upfront investment. There's no software to install. There's no hardware to install. So that means that there's no maintenance for you to do. It's very easy to set up. You just have to create an account and log in. We provide seamless collaboration within your organization, and we also provide world-class support. There's support embedded within the software so that you can speak to our experts to help you with your simulations. We leverage the capabilities of cloud-hosted software, and this means that computation times are typically measured in minutes as opposed to weeks. And because we're running everything on high-performance clusters on the cloud, you can set off as many parallel simulations as you like. Okay, that's all from me, so I'll hand over to Darren now.
Thanks very much, Steve. So yeah, I'm going to talk to you about the main topic of today's demo, and that is pedestrian wind comfort, specifically on SimScale. And I'm going to kind of go through a few slides introducing you to the topic. I'm going to show you a platform demo, and then we're going to kind of key results and have a discussion session at the end. So once again, a reminder, if you've got any questions either now or throughout the demo, then feel free to ask the questions in the question section of this meeting. Great. So onto the agenda. As I mentioned, a quick intro to pedestrian wind comfort. I'm probably going to refer to it a few times as PwC. We're going to discuss how to set up a PwC simulation in SimScale. I'm going to do a live demonstration, as mentioned, key results, and then the QA session at the end. Firstly, discussing what pedestrian wind comfort actually is, in case anybody is unfamiliar. So pedestrian wind comfort is the name given to analysing comfort around an urban area on a pedestrian due to the effects of wind. Now, the buildings that we actually design and we analyse can drastically affect the comfort with some wind interactions, which causes some discomfort at the pedestrian level, so actually where the pedestrians are standing. So the whole point is we're going to be looking at either the building we've designed or some area of interest to assess the comfort level at that pedestrian level. And more importantly, how we can use CFD or SimScale, in fact, SimScale's implementation of CFD and its pedestrian wind comfort implementation to actually get these results. Now, we've highly automated this process, so it's not going to take a long time to actually get through this. But it is very detailed also, so it's simple and detailed to actually cater for many different variety of simulations scenarios. Good. So I'm going to firstly talk about the demo that I'm giving today. So the demo I'm giving today is specifically on an area around Bristol, actually just to the north of Castle Park. On the right here, you can see the Google Earth image of the area of interest. So this is a small block here, and you've got some notable features there. So we've got a very tall building on the right-hand side, a little circular section on the left, and the part of the park is visible in the screenshot. Now, if we compare that to the geometry that we're using today, we can see that we've got a very good similarity between the two. So you can see this tall building, but not only can we see that, we can see the level of detail in the park. So we've got a good correspondence between land use, trees, presence, and that expands to the main region of interest, this central section here, where we've got a few trees of interest there. Now, this beautiful geometry is provided to us today by AccuCities, so I've got to give a shout out to them for doing this marvelous geometry. I've also posted a link there. So what we're going to be doing is we're going to be looking at this particular geometry. We're going to be taking it, we're going to discuss what we needed to modify to actually make it work for pedestrian wind comfort, then upload it to the SimScale platform and set up a simulation. And finally, we're going to look at the results, and not only look at the results, but also how can we interpret those results to understand comfort, and also how could we mitigate some uncomfortable areas based upon those results. So another slide on the geometry. This is mainly on AccuCities. Obviously, a big shout out to them. You can go to their website today and look at all sorts of the models available. Now, they do other cities, not only London, Bristol, Birmingham, they also do. You can just check out our website, and you can even download some of the free samples, which is actually what we've simulated today. So the next section is the preparation. What did we actually have to do to this geometry that was supplied to actually get it to work with SimScale? Now, the key thing about this particular geometry is that we've got topology. So by topology, we mean we've got an uneven terrain that goes up and down and goes up with the contours, etc. And we've got a hilly section that represents where the park actually is itself. Now, usually this adds some extra complexity, and to deal with this, what we need to do is we need to make sure that this surface representing the topology is going to be extended all the way to the domain boundaries. So the wind tunnel's extremities, we need to extend it all the way out to. And that's exactly what I've done here in the center. So I've taken the edges of the city and I've just extended it out in a circular manner. And in general, if you're going to be uploading geometries with topology, this is going to be the requirement that we ask of you. And this simply stops flow moving under your city. So if you were to put this in a wind tunnel, without this extension, flow would go under your city surface as well as over it. And this avoids that error. Next in line is to actually set up the simulation. So we've modified this geometry, we've uploaded it to the SimScale platform. What do we actually need to do to set up that simulation? And luckily, we've done a lot of work here to actually automate this. So it can be reduced down to 3 simple steps. This would approximately take 2 minutes to set up after you've uploaded it to the platform. And the main things that we're looking for is to firstly define a region of interest. So this region you can see on the left here is actually a circular region. This represents where we're actually going to export results from. So if we've got a much larger city, but we're only interested in a certain smaller part, then we would draw this circle around that smaller section. The next step would be to define a windrose. This is the weather data. So where in the world are we, and what is the weather doing at that particular location? And actually in SimScale, this can be as simple as just typing your location. So in this case, it was just type in Bristol, and we would import the wind data for that. Now I'm going to show you these steps live as well to show you how easy it is. And the final step is actually defining the pedestrian zones. So that is any surface where a pedestrian might be considered standing. In this case, it's everywhere on the city surface, so on the roads, on the pavement, on the park areas. But this could also extend to balconies, terraces, bridges, for example. Anywhere the pedestrian is going to be standing, we can select it as a surface and offset that as our pedestrian surfaces. And that is the 2-minute setup complete. Once we've done those 3 steps, we can actually go through and start a simulation. So it really is as easy as that. And what I'm going to do is I'm going to move over to the platform now. I'm going to show you this live very quickly. And then I'm going to come back to the presentation to show you some key results from that. So let me exit the full screen. There we go. And hopefully now everyone can see the SimScale platform. Now, this is, in case you're not familiar with SimScale, this is SimScale just running in Google Chrome. What we've got as a user interface is this rather large viewer in the center here. This is where we would view any results, where we would view the model that we've uploaded, but also where we could make graphical selections and assignments. And on the left-hand side here, we've got the simulation tree. So this is where we would actually do these technical parts. So this is where we would define the region of interest, where we would go wind conditions, etc. This is the area that we're going to be concentrating in. But also we would upload the geometries here as well. Now, just as a prerequisite, the geometry was already uploaded in this case. It was uploaded as an STL file. Now, STL files are considered to be the most robust for this type of analysis. And I think most tools used in this industry would happily export an STL file as well. And for reference, this also came from Rhino. This is where the geometry originated from. So I'm actually going to start from scratch. I'm not going to go through the setups that I've already done. I'm going to go from scratch and show you how I set this simulation up. So the first thing I would actually do is I would go to simulations. I would press this little plus button, and this is where we get a list of all the different types of analysis that SimScale can do. But the one we're actually interested in today is pedestrian wind comfort. Now, pedestrian wind comfort, a 2-minute setup. So this isn't going to take very long to get through. First thing to note is that the geometry that is selected is the latest geometry that you've uploaded. And we can simply go from here to the region of interest. Now, this region of interest is simply defined as the center point and a radius. So all I'm going to do is I'm going to recenter that to 0. And I'm going to call the radius, I think it's 150 meters. There we go. Just to include most of that area there as well. Next up is to actually define the wind conditions. This is a little bit magical, this step, because all we do is we go Bristol. There we go. We can see it come in the drop-down box, and we can import that data from Meteor Blue. And this gives us, by default, a number of directions of 16 different wind directions. We can just cut that down to whatever we fancy at the time. For this stage, I'm going to say that 8 directions is probably the most suitable number of directions, and we can save that as our selection. And finally, what I'm going to do is I'm going to select a few surfaces. I'm not going to select them all, but just to show you what the workflow is, I'm going to select some pedestrian surfaces. I'm going to create a new surface. We can select what height people are going to be standing at, or what height we're going to be measuring comfort at. Typically, I use 1.5 meters, but some other standards specify 1.75 meters or 2 meters, depending on where in the world you are. And this can be as easy as graphically selecting in the viewer, or we can select actually an entire layer. So we could select an entire patch, terrain, and you can see that all of these are selected together, which is nice and easy. Now, we can then go straight to simulation runs, and it's important to note that at this stage we're going to get a little sanity check on the simulation. So it's going to go, okay, based upon all these inputs that you've given me, have you done everything correctly, or is there something that you could improve? So I'm going to press the little plus button, and it's giving me actually a little warning. It says you've left something as a default condition. I'm going to acknowledge that, but say I'm going to run it anyway. And after which we get a little estimation. Now, this is very handy because it allows you to actually understand how much compute resources you're using, how long it's going to take to actually run the simulation, and also what resolution you're going to get results out as well. And we can press start, and this is going to start running a simulation. And then I think it was like 50 minutes time is the minimum that's going to actually return these detailed results back to us. So instead of waiting 50 minutes, I'm actually going to go to a simulation that I've already run and show you some of the key results of that. So I'm going to go back to my latest run, which is this one here. And the first thing to note is under the run one, we get a few different types of results. We firstly get the statistical surface solution, which is where we store pedestrian comfort, pedestrian safety, and all the statistical type results. But we also get directions. Now, directions are, we're going to get a different set of results for every single direction that we ran. In this case, we've got 8 different directions. We're going to get the average velocity and transient velocity for each one of those individual directions as well. And you can view those just by expanding one direction and viewing them. So although we've automated this heavily, we've got all the results here for you to view if you need to. But the one I'm going to show you today is the statistical surfaces, so the pedestrian comfort, just to show you how the results look on the platform here. Now, depending on how big your simulation size is, it might take 1 or 2 minutes to actually load in. I think I timed this one, it was like 20 seconds or something, so you won't be waiting long. But whilst we're waiting for it to load, I'm just going to touch on a few points. The first point is, of course, you can run as many simulations as you want at once. So, for example, if you wanted to test before a development and with a development, then you could. Ultimately, you could also test, say, 5 different designs with 5 different mitigation techniques. You could test all of those simulations at once as well. So, a huge amount of power from cloud computing. And also, just to note here, if at any stage you've got any questions about simulation setup, documentation, got questions on what you should be putting in this place, etc., you can also contact us at any point. So this little chat function here basically opens up a line of communication between yourself and either me or one of my colleagues. And this allows us to actually dive into the project together and actually find a solution to any question that you've got very interactively. So this is a fantastic level of support offered by our team. So what you can see is results have actually loaded into the viewer. You can see here, if I go to the top-down view and zoom in a little bit, you've got various different colors. And this color is also described in the bottom left in the legend. And they mean various different things. Okay, so we've got some blue areas here. We've got some red areas as well. Now, what people typically mistake this as something that would be uncomfortable or something that would be comfortable, but it's not actually the case. What you've actually got to consider is what an area would be considered to be doing. So if a pedestrian was in this area in the center, what would he be actually doing? Would he be dining in that area, or would he be walking, or would he be standing, waiting for something? Alternatively, in this area over here, someone might be waiting to cross a road. So we've got to consider the activity that they're going to be taking at each of these points. And then we look up if they would be comfortable doing said activity. So if I actually look in this area where they might be dining, we can actually see that they would be comfortable doing that. Alternatively, in this area here, they might be waiting to cross a road. There might be a zebra crossing, in which case they wouldn't be comfortable there because they'd be waiting for an area that is only good for business walking. So that wouldn't be a good use of that space. So I'm going to go back to the slide deck now. Just a few slides before we hit the end. I'm going to carry on presenting, and this is where I'm going to take a deeper dive into those results that I've just showed you. So we've got the pedestrian wind comfort map, as I described it just a minute ago. I won't go into too much detail, only that we've got various bins which we store this data in. This separates down into velocity bins, so wind speeds that is going to happen at various points, and also probability of exceedances, and that's how we categorize this comfort map. But what's most important is that this is the Lawson criteria. We're using Lawson LDDC criteria. We've got many others available on the platforms, many other iterations of Lawson, but also we've got NEN 8100 and Davenport, which might be more suitable to you in different parts of the world. Good. And finally, so we've understood how to read the statistical surfaces, but what's also important from this simulation type is to actually understand what the relationship between the comfort is compared to the velocity results, and how we could actually mitigate some of these poor comfort areas. So we've got a list of 3 different things that we're looking for actually in these velocity results. The first thing is downwash, where higher speed velocity from further up in the atmospheric boundary layer can be washed down onto pedestrian level. We've got cornering effects, where sharp corners in buildings could be causing some bad pedestrian comfort in those areas. And we've also got channeling, where flow is actually trying to go between 2 buildings. It's being forced between those buildings, and therefore it's speeding up its wind speed and negatively impacting the pedestrian comfort. And what we could draw conclusions about in this case is we could say put some trees, some screens, some canopies in to actually mitigate some of these effects and improve the comfort in these areas. So hopefully that gives you a good rundown of the SimScale implementation of pedestrian wind comfort, and also pedestrian wind comfort as a whole. Now, this is the QA session, so if you've got questions, then start typing. But otherwise, I think, Steve, I'm going to hand it over to you.
Yeah, thank you very much, Darren. That was great, very informative. And yeah, it looks like we've got quite a lot of interest on the questions. So the first question that's come in is, where are the wind conditions taken from, Darren?
Sure, so the wind conditions are actually taken from a service that we connect to called Meteor Blue. This is an incredibly intelligent service where we can define actually specific locations, and it will basically interpret the results or the wind conditions to that location. So it's a very handy tool, and as you saw, it makes it incredibly easy that we could just type in any location and we would get the wind data for that area.
Great, thanks for that. Another question that's come in says, do you need 3D CAD or can you upload map data?
Yeah, so very important point. So we support 3D uploads only. As I mentioned, typically an STL file is the best, but we do support many other file types such as Parasolids. We've also native Rhino, native Revit files as well. So many different 3D formats, but they do need to be converted to 3D prior to upload into the SimScale platform. Okay,
so there's a couple more questions here. Another question is, what turbulence models does SimScale support?
Yeah, so the pedestrian wind comfort analysis type specifically supports what we call a hybrid model. So it is a large eddy simulation model coupled with a K-Omega SST wall model. What this means practically is that we deal with the wall model much better. So we don't have to have a super high resolution mesh near to the wall itself, but we can actually get away with a coarser one. But then this transitions somewhere in the buffer layer to the large eddy simulation, which is much better for predicting separated flows, which traditionally is what we're dealing with for external building aerodynamics.
So another question that's come in is it possible to see wind speed averages for speeds meters per second that I want?
So No, it's quite unique what SimScale does. I think if I understand correctly your question, can you change the speed in which we run the simulations at? The answer is actually no. What we do is we test it at one standard speed, and that is simply 10 meters per second at 10 meters height in the atmospheric boundary layer. We then use best practices to do a conversion from that to the weather data. So the weather data might say for, I don't know, 5% of the time in a year, we might be have a wind direction from the northwest at 5.6 meters per second. So then we would scale those results to that wind condition. And that's essentially what it's doing in the background, and that's how we calculate the pedestrian wind comfort map. And what you see in the velocity results will be therefore the reference results, which is at 10 meters per second.
Okay, please let us know if that didn't answer your question, and we can follow up.
Yeah, definitely. It should also be noted, of course, that we've got the Lattice-Boltzmann method, which is kind of what the pedestrian wind comfort is based upon. And of course, this gives you full control over that. So if you wanted to upload an atmospheric boundary layer of any reference speed, then that's absolutely possible as well.
So there's another question that's a bit more focused around the platform itself, and someone's asking whether they can try SimScale.
Of course, yeah. So anyone can try SimScale. You can actually sign up for a community account, and this will give any personal users and academic users free access to the platform itself with some restricted access. Now, it should be noted that the pedestrian wind comfort and the Lattice-Boltzmann method are both pro features. Therefore, you would have to either be using this commercially or academically to a higher level to actually get access to those simulation types.
Great. Okay, so we've got a follow-up question on that previous one, Darren. Saying, what if I need to view results at 6, 9, 15 or 20 meters per second? What would be our solution there?
Yeah, so if you did want to view those results, then there's nothing wrong with you scaling it yourself. So what we would typically do is we could essentially scale it by doing the velocity divided by the reference velocity and then multiplied by the velocity that you actually want to see. I think it is a little bit more complicated than that. We have got full documentation of what we do for the pedestrian wind comfort behind the scenes, and therefore there might be a few different extra calculations that you need to do, but that would be the solution. It would also be an offline solution. So on the back of that, I should mention that you can, of course, download all of these results and post-process them or store them locally if you need to.
Yeah, that's a very important point. Everything is extractable if you want to post-process. Okay, so I think we've just got time for one more question. So another question we've had in is, does the program adapt according to the geographical alpha?
I knew you were going to ask me that one as well. I'm not actually sure 100% what you mean by that, but I'm more than happy to correspond after the meeting. I've got a list of attendees, so I'll reach out to you in person.
Okay, that's great. Yeah, we'll follow up on that one. So thank you for everyone who's attended. That was a great turnout, and thank you for all the questions. See you soon.
Great.
Thanks.
Thanks
Bye.
very much, everyone. Bye.